All right, you guys, welcome back. We're gonna continue working on section 9.1, which is properties of radicals. Um, Hopefully my technology decides to actually work today, but we'll see. Always an adventure. All right, so you guys, we have been working, or yesterday and today we worked a lot on like just identifying, like if we have a division or the quotient property that we're using, we can break these up into two separate things. And for the last couple, we've been really, really lucky that they have been nice, perfect squares in the denominator. That's not the case anymore. Okay? You are going to have to learn the property or the process of rationalizing the denominator. Okay? So that's exactly the process that we're looking at with these couple of problems here is rationalizing the denominator. Okay? So make sure that you are able to follow along with this. And if you have questions, let me know. First thing we want to do is we want to look at the index. Remember, if there's nothing inside of the index, it's automatically a square root. Okay? So what we are going to end up doing is for this one, like for part A, we're going to start by multiplying exactly the denominator by itself. Okay? And what you do to the denominator, you have to do to the numerator. Okay? Now, here's why we're just multiplying this by itself. What ends up happening is we multiply everything inside of the radical together. So 3 times 3 gives you 9. And then n times n gives you n squared. Okay, so now when you take this denominator, it actually just turns out to be this exact same thing without the root sign, right? Square root of 9 turns into 3. Square root of n squared turns into n. So when you multiply it by itself, it just turns into whatever's underneath the radical minus the radical sign. Okay, so then if we just kind of point our attention to the numerator really quickly, we take, again, whatever's underneath this radical sign and we multiply it together. So 5 times 3 turns into the square root of 15n. Check to make sure that there isn't anything that you can pull out of there, right? If I start thinking about my perfect square numbers, 1, 4, 9, 16, 15 kind of falls right in here. None of these three are going to be able to come out. So your answer is just going to remain the square root of 15n over 3n. Okay, now the reason that I mentioned the index before is because with this next example, there's two ways that we can do this. Okay, method number one, and this is kind of the method that I like just because I find it to be simpler. Method number one, we can take and we have to multiply. We have to make sure that we have this same factor, the index number of times. Okay, so since there is an index of 3, we have to have 3 of these cube root 9s. Because if you take, again, kind of just breaking this down really, really far, and I know that you're probably super confused right now, but just stick with me. Take 9 times 9 times 9 in your calculator. Make sure you've got your calculator handy. 9 times 9 times 9 turns into 729. Okay. Now, try taking the cube root of 729 in your calculator. So the cube root of 729 turns into 9. So basically what's going to happen is you're going to end up getting this cube root of 729, but again, that's just going to turn into whatever's in this denominator without the root sign. Okay. So now, again, whatever you do to the denominator, you have to do to the numerator. So you multiply the denominator by 2 of these cube root 9s. You have to multiply the numerator by 2 of these cube root 9s. Okay, so let's see, what will we end up having? We would end up having, this will be 2 times the cube root of 81. Okay, so then again, we kind of have to start thinking about, like, okay, the cube root of 81, does that work? So if I just try and figure out cube root of 81, okay, that's not going to work. What are my perfect cube numbers? Can I pull anything out? So again, if we just kind of remind ourselves, 1 cubed is just 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed, I believe, is where we get, okay, so 5 cubed is 125. Okay, so this 81 again kind of falls right between these two. If we just kind of start dividing, 81 divided by 64, okay, that doesn't work. 81 divided by 27, okay, so 81 divided by 27 gives you 3. Okay, so let's see, the cube root of 27 is 3. So this is going to turn into 2 times 3 cube root 3. Okay, now again, let me just do a little bit of back work here. Remember, this cube root of 81 is being broken down into the cube root of 27 and the cube root of 3. Cube root of 27 turns out to be 3. And then that's the cube root of 3. So this is right here. Okay. Not quite done yet. 2 times 3 turns into 6. So this is 6 cube root 3 over 9. This stuff right here can be simplified. Definitely not what I was trying to do there, but oh well. Okay, so 6 over 9 can be simplified. That would be 2 cube root 3 over 3. Okay, you guys, if you are confused by this problem, that is totally okay. Do not freak out. We will do extra examples. Your task is going to be to work on problems 13 through 16. Very similar type of problems. I just noticed that there aren't any cube root problems on them. Number 17 on the next page has a cube root. We can talk about that one tomorrow in class, just so that we get more experience with it. I get this is kind of a totally new topic. It's kind of coming from left field. So if you're confused, don't worry. We'll talk more about it. Okay, now letter C. So my goal, you guys, is to do letter C and then do the first word problem on the next page with you. So I've got 2 problems left to go through. And my technology has not stopped on me yet, so we're going to call it a win. Okay, so right now we have a root in the denominator. Again, we talked about that today. You cannot have a root in the denominator. Okay, so what we want to go through and do is we want to take, and here is where a lot of you guys were asking today, like, what's the conjugate? What's the conjugate? This is the conjugate. We're going to take the opposite of this, so we're just basically going to switch the sign here. We're going to multiply by the conjugate, okay? Now here's why. You guys have gotten really, really good at this whole foiling thing, multiplying first, outsides, insides, lasts together. You want the conjugate because you're going to end up getting rid of that middle term. That's going to turn out to be super, super icky, and I'll show you guys that. So when you multiply the firsts together, okay, here's your firsts, outsides, insides, lasts, and again, you guys are good with this stuff. Oof, that got a lot darker than I wanted it to. But here's where we're at. Firsts, 2 times 2 gives you 4. Outsides, that's 2 root 3 plus 2 root 3. Insides is negative 2 root 3. And then the lasts, that gives you negative square root of 9. Okay? These two things, super, super icky, and we don't want them. They cancel each other out. Okay? Now, some of you might be thinking, but Mrs. Granton, there's still a root in the denominator. Yep, kind of is, but take a look. What is 9? 9's one of our perfect square numbers, right? So this just turns into 4 minus the square root of 9 turns into 3. Okay, so that ends up changing. And then we'll end up simplifying that in just a second, but I want to kind of go back and finish up this top part here. So if now we've got to do the distributive property. So 7 times 2 gives you 14, and then 7 root 3. So that's 14 plus 7 root 3. And then if we just take that last step, that's unfortunate. That's not what I wanted. 14 plus 7 root 3, and then over 1, because 4 minus 3 is just 1. So even if you just wrote down 14 plus 7 root 3, that's really all you need. I don't think your book is going to make you write this over one piece. Okay, so that's, you guys, that's the conjugate. Okay, conjugate is just the opposite. So let's say we had something like 2 plus the square root of 7, let's go with. In order to get this root away in the denominator, you're multiplying by its conjugate, which would be 2 minus root 7. Okay, conjugate's just the opposite sign. And again, I just demonstrated that here with this problem. You want that conjugate, you need that conjugate in order for these middle two terms to go away and for this last term to turn into a perfect square so that you can simplify. Okay, so now what I think is best for you guys is to go through, do 13 through 20. 18, 19, and 20 are all those conjugate problems. So try them. And then I am going to do the last word problem with you guys here on this video, and then I'm going to be done. So hopefully, I guess I haven't even looked to see how long I've been on here. Oh, not too bad, because this last one is fairly quick, actually. So, word problem. The distance in miles that you can see to the horizon with your eye level, h feet above the water, is given by this function here. D equals the square root of 3h over 2. How far can you see when your eye level is 5 feet above the water? Okay, so we've got this person standing here. Remember, h is feet. So realistically, you guys, they just want you to take 5, plug it in. But for practice purposes, and I know we talked a little bit today about how the only way for you to get better at math is to do this. So I know that a lot of you are just like, well, why can't I just type it in my calculator and be done? Yep, you can. And that's essentially what you're going to end up doing. But remember, we want to get the practice. We want to get better at this. Okay? So we're going to take the long road here, and I'm going to do my explaining. So this is the square root of 15. 3 times 5 turns into 15 over 2 through the quotient property. Remember, we are able to just take and split this up into the square root of 15 over the square root of 2. We are going to multiply by, again, just think about this, our index is 2. So we're going to multiply by the square root of 2 in order to get these to cancel each other out. So the square root of 2 times the square root of 2, that turns into the square root of 4. And then simplified down is just 2. Square root of 15 times the square root of 2, that'd be the square root of 30. Square root of 30. And again, if we just kind of start thinking like, okay, there aren't any perfect squares that we can take out of there. And whenever we're talking about a distance, it doesn't really make sense. We don't have the full number sense to remember, well, the square root of 30 is approximately, you know, yada, 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 whatever. But remember, we always talk about distance because they want us to figure out how far can you see. So yes, this is an instance where you would just take the square root of 30 and then divide it by 2. So when you do that, that turns out to, so make sure you do this on your calculator on your own so that you make sure that you've got it. But it does turn out to be approximately 2.74, let's see, miles. Okay, because again, we have to take the context of the problem, and it doesn't make sense, like I said, to have a square root as a distance. Okay, I am done. Go ahead, make sure that you get problems 13 through 20 done so that we can talk about those tomorrow and get more practice with them. Otherwise, have a great night, and I will see you guys tomorrow. Bye.